We can read down to 3 decimal places. So now the voltage, is that the voltage? It's not the voltage. It is the wire twist angle. It's going to be 1854. I don't think that this will behave properly. No. All right. I'm just going to go ahead and continue because I don't remember what I did last time. But I know I need this in this format. I really want to take it make use of the power of Excel. So that's not one. All right, so we have all of our data points here to do the proper assessment. So we have our distance. What we need is the distance squared. The inverse of the distance squared. So inverse of the distance of separation between the spheres squared. So this should be 1 divided by a meter. Squared. That's going to be, 1 divided by power. And this is our distance in meters squared. But it should look very similar to what you guys had. And I don't want all those decimal places. All right. I think we can do well. I'm just gonna leave it like this. And then we're going to find the force acting on it. So this is the electrical force. And we know that this is in newtons. So that's going to be our K. So I don't really like to just refer to other pages without having some explicit thing. So I'm going to say that this is going to be equal to where's our K? There it is. Spring constant. All right. And then this is going to be just equal to oh my gosh. Scientific. All right. All right. So our electric force is going to be equal to our wire twist angle, average wire twist angle times the spring constant, which I'm going to make constant. I'll pull this down. So now we have our inverse square distance. We have our electric force. We know that the inverse square distance is going to be on the y-axis, and the other one is going to be on the x-axis. I'm sorry, the inverse square distance, the inverse of the distance between the spheres squared is going to be on the horizontal axis. The electric force acting on the spheres is going to be on the y-axis. So I'm going to use the Linus function. Known y's, okay. Known x's, okay. I can say false, I can say true, and we get a force here. So this is not the force. This is our measured value. All right. This is what we're measuring what we've expected, and what we've expected we highlighted in green. This is what we measured. I'll highlight that one. In green. Now, let me see. I want to change this to true. All right. So two things are happening here. I actually have 2 points that are not supposed to necessarily be in there. So I'm going to go back and put this as false. And I want to change my range to, I think, 8. Yep. And I'll put it at 8 over here. So some nonlinear effects are taking place when I put these numbers in. And I'll just make them red. Okay. And now let's just go ahead and calculate our compare them using the percent error. Arrow. Arrow. So this is going to be equal to our parenthesis, and then we have our expected minus. And we're going to divide that by what we expect. Go ahead and make this into all right. I am going to stop right here and let you guys ponder how well we're in agreement. Um, so we have our distance of 5 points. That's great. And next we'll do the one at 30 points. I'm expecting this to decrease. Okay, that's my expectation, but it may or may not. All right. Save your documents.